So today let's solve 19, remove nth node from end of list. This one's a simpler one of the medium problems. But what we have here is we're given a list and we are supposed to remove the nth node. For example, we're given 2. That's starting from the back though. So let's say 5 is 1, this is going to be 2. Let's say if we're given n equals 3, that's 1, 2, 3. We want to remove this one. All we're doing here is removing this node and pointing 3 to 5. That's literally all we're doing. So let's copy that exact example, but with 2 pointers this time. Let's use a left pointer and a right pointer. And since we're given n equals 2, we're going to move it forward. We're going to move the right pointer by those two, the n equals 2 we're given. So let's move that over here. And now what we're going to do is we're going to move R and L, left and right, up until right no longer exists. It is equal to null. Next iteration. Next iteration. And as you can see here, we got a big, spooky, scary, null right pointer there. And we can't do anything with this because we can't go to the previous node and say current, previous, because we don't have that. And we're supposed to do it in one pass per the Leetcode problem. So what we're going to do here, we're going to use a dummy node. We're going to put that at the front here. We're going to make it look like a box. So not confused with anything. Down here. Stupid. Right? And we're going to leave the left pointer there. We're going to point left at dummy. And we're going to point the right at head. And we're going to use a loop to move R, the number of partitions, or no, not partitions, the number we're given here. So that's 1, 2. And now we're going to do the exact same thing as the last step. And we're going to move it by one step every single time. So first iteration. Second iteration. Third and final iteration. Well, voila, why won't you look at that? We have number 4 isolated, and we have a direct pointer right here to it. So what we can do is point it at 5 and completely pretend like this one never even existed. Now let's go ahead and code that. So what we're going to do is we're going to set the dummy equal to the list node with a value of 0, whatever value you want, pointing at the head as we showed in the example there. And we're going to set the left equal to the dummy, like we said, and the right equal to the head. And while n is less than 0, and right is not equal to null, and it still exists, then we do right equals right dot next, and n negative equals 1. And while right still exists, left equals left dot next, right equals right dot next, and left dot next equals left dot next dot next. And that was to show you as here, because left dot next right now equals 4. If we're doing this example, 3 points to 4, we want it to equal to 5, so we can completely pretend like that 4 never even existed. And then we obviously don't want to return the dummy variable, or not the dummy variable, the dummy list node that we gave. So we return dummy.next. Ooh, dummy.next. Let's go run that. Boom, there we go.